I would like to start by acknowledging the Ngunnawal and Ngambri people as the traditional owners of the lands on which we're meeting, and pay my respects to First Nations people joining us tonight, both in the room and online. And thank you so much to all of our audience in all those places that you are. I'm really thrilled at the turnout for tonight's event. I'm also really excited to bring together three incredible researchers to talk about a topic that I'm personally very passionate about, which is the aesthetic and visual representation of weather and climate. So we welcome tonight Leah Beeferman from Providence, Rhode Island, where she teaches at Rhode Island School of Design, also known as RISD. RISD has been a partner with ANU School of Art and Design before on exchange programs, so I'm really happy to be kind of fostering that connection. Leah works with digital image making, video, text, and sound. Her work explores and abstracts the shifting relationships between measurement and uncertainty as they relate to landscape and weather at a variety of scales. Her recent solo exhibitions have been shown at the Penumbra Foundation in New York and at the Pia Art Center in Indiana. With her focus on weather as explored through residencies and collaborations with scientific partners, Leah's work aligns with the cross-disciplinary research and practice-led approach taken here at the ANU School of Art and Design. So to put this into action, we decided to expand Leah's talk into a dialogue with scientist Andy Hogg to consider together across disciplines the research practices that share the challenge of how to make complex environmental data tangible, compelling, and emotionally resonant. So Andy Hogg is an oceanographer who specialises in modelling the Southern Ocean. Andy did his PhD at the University of Western Australia and has worked at Southampton Oceanography Centre as well as the ANU. He is currently the director of Australia's climate simulator, ACCESS-NRI, and a chief investigator of the ARC Centre of Excellence for Weather of the 21st Century. I'm sure Andy will talk a lot more about this, but ACCESS is the Earth system simulator that works on atmospheric, ocean, sea ice, and land surface computer modelling frameworks. So that's why I thought that this was a perfect conversation to have with Leah. It contributes to IPCC reports, seasonal and regional forecasting, and climate adaptation policy, among many other things. After hearing from Andy and Leah tonight first, who will both introduce their work, we'll then come together for a panel discussion led by Pia Van Gelder. Pia is an electronic artist, researcher, and historian whose art practice and writing investigates historical and contemporary conceptions of energies and how they shape our relationship with technology, bodies, and our environment. She's also very good at asking questions, which why I asked her to come on board tonight. I mean that in the best possible way. In talking to both Andy and Leah about their work individually in planning this event, common words have emerged in the task of translating systems and phenomena that are distributed across time and space. Scale, uncertainty, measurement, and modelling are all key ideas to both of their work, but they can mean different things from different disciplinary perspectives. And they also result in different images, aesthetics, and outcomes. So I hope that in discussing these approaches together tonight, this conversation can explore both the limits and possibilities of aesthetic representation of weather and climate, to ask how art, design, and science can work towards strategies that can contribute to deeper understanding of environmental narratives and speculative futures as the realities of climate change become increasingly urgent and under-supported. So with that, I'm going to ask Leah to come up and also start the screen sharing. Great.
Okay, great. Hi, everybody. It's great to be here. Thank you, Anna, for organizing this. And I'm excited to talk to Andy and Pia after introduce my work. So I like to start now with this image because I feel like it encapsulates a lot of what I'm sort of interested in broadly, and I'm going to show a few different kind of series of work. And I'm an image maker primarily. I also work with video and sound and text sometimes, but my kind of primary interest is in images, and this question of sort of started with how can you represent a landscape, which is something that changes so drastically over time, but also changes very much because of weather. And that led me to get into weather and further into sort of atmosphere and clouds, which I'll talk about a little bit more in a minute. But I think in investigating different landscapes over the years, there's, I think I was immediately struck by this very kind of straightforward photography question, which is, what's in the frame and what's out of it, or what can be captured by a camera and what can't. And I started to feel more and more like what I was trying to capture could not be captured. There was too many kind of, I don't know, just too many limitations. And so I became interested in the possibilities of that limitation rather than like the frustrations of it. And through that, I've sort of built these different practices. But in that sort of investigation of limitations, I also I've had a kind of ongoing interest in scientific equipment of different kinds, starting with satellites that we send off or used to send off to see things for us in outer space, and gradually the tools that we use to image aspects of the climate or the landscape or the atmosphere that we can't directly see with our own eyes. And so one of the reasons that these scientific images of different kinds have fascinated me over the years is because they're meant to be informational. And for people who know how to read them, they are information, but to everybody else, they're just an image and they're abstract. And I think that there's a kind of interesting parallel between art or art images and scientific images, in the sense that, with art images, there's this sort of expectation that anyone can walk up to an artwork and say like, oh, I can react to this. But actually there's a lot that's been coded into artworks in their own right. And so, yeah, the idea that, one needs information to understand something, and whether you have it or not is something that sort of goes along with my work in general. So anyway, fast forward to 2024, and I'm going to jump ahead. I visited this place, which is a bunch of containers on the coast, the eastern coast of Barbados in the Caribbean, where they have the Barbados Cloud Observatory run by the Max Planck Institute in Germany. And I went there because I had learned that clouds are the greatest source of uncertainty when it comes to climate change, which I did not know, and that kind of blew my mind when I read it. And, longer story, but at some point a few years earlier, I had come across a research group called Cloud Scale Uncertainties out of Germany, which I thought was like the best title for anything ever. And so I stole it and used it for my show last year. But basically, I was really captivated by the idea that something as ubiquitous as clouds could be, and something that we kind of think is so friendly and familiar, could be like a source of this uncertainty. And I wanted to investigate that. So I went to Barbados to see what was going on. And there were many things sort of happening there, but one of them was this amazing machine called the Raman LiDAR, which is in this box there on the left, which is just like a big green laser that shoots up into the sky for 24 hours a day, and things bounce down, and then they make these amazing images, which I dug out of the the files on their website and then proceeded to use, which is kind of what I do a lot. And this was I've worked in this kind of collage process. I don't love the word collage, but for lack of a better word, a digital collage process for a long time. And I'll show more of that work in a minute. But this piece was exciting for me because it was the first time that I was really putting together images that I had taken of things that I was looking at with the view of the machine at the same time. And they're not one-to-one clouds. It's not like that cloud is this cloud, but it's the same day, similar time frame. And so this sort of practice of putting together things that I've made with things that computers or machines have recorded or translated in some way is something that I've been investigating a lot recently in a few different projects. This is an image of the show at Penumbra in New York from last year, part of the room. And just to give a sense of like size and physicality of these pieces. And which leads me into this next series, which is called Weather of the Weather. And I started this 2 years ago, and I basically got interested in downloading a variety of weather maps from mainly from NOAA in the US, but some from EUMETSAT in Europe also. And I just kind of dig around the internet looking for where I can get interesting looking images. But, you know, here's a detail, it's a little bit dark. This one I really like just because the US looks like it's in chaos, which we all know it is, even though this was 2 years ago. But basically, with this series, I wanted to, yeah, I was interested in sort of seeing what the possibilities were in 3D space. And so I started making these sort of strange amorphous forms that aren't really like clouds. This kind of preceded the cloud interest very specifically, but it was inspired by, in part, just being in a plane and seeing clouds casting shadows on a landscape, and then thinking like these shapes are casting shadows back on the weather, which, you know, in some way feels indicative of what is going on in the world in terms of us impacting the weather in a very indirect way. But I think with all of this work, there's an interest in abstraction, and there's an abstraction of both the natural elements in the world, with sort of that's coming from this idea that, you know, we've all seen a cloud, but how can you make a cloud interesting in an image? How can you make someone look at it and not think they already understand it? Or how can you show a leaf and make it seem like it's not a leaf that we've seen before? And so abstraction is a tool for me of kind of recontextualizing things, putting them in a new frame to hopefully get people to reconsider their relationship to them. And so in that same way, I think a lot of people tend to look at scientific images, and at least in my experience, a lot of people are like, that's science, I can't understand it. And, you know, I'm not trying to teach you anything with these, and I'm not trying to, you know, like deduce anything either. But I am interested in the idea of bringing them into a new space to sort of expand the possibilities of what these images can bring and can convey. And then another thing with these images that interests me, and, you know, is that in my kind of thinking about them and my understanding of them, most of them are meant to be captured in sequence. And so it's like, you know, you have a string of these because the string of them tells you something about how a system is evolving. But if you pull one out, I don't know if that one really means that much. You know, like maybe there's something really interesting going on, but I think normally, this is just me, no one's ever confirmed this. But you know, it's just like, it's like a snapshot of a moment in time. It's like taking a picture of a landscape, and it's just like, this was how this was at this moment. And it doesn't really tell you necessarily like, you know, a huge amount of details about how something is evolving. So, yeah, so in that way, pulling these images out of their sequences sort of renders them kind of useless in a way. And I've had a number of artistic crises about, like, you know, taking something that's meant to be useful and stripping it of its use value, and feeling like, who am I to do that, especially if this is, you know, important, like research in some way. And then I would absolve myself by sort of reminding myself that I'm not a scientist and I'm not trying to answer those questions. Other people are doing that, and I can ask my own questions. And one of the questions that I'm interested in, as Anna mentioned, is how we deal with uncertainty. and this relationship between measurement as, I think there's a perception that measurement is like some sort of act of certainty, but I don't know that it actually always is. And so, yeah, when I was thinking about, let me skip ahead here. When I was thinking about this idea of a cloud scale uncertainty, there's something really like exciting about an uncertainty that big. But at the same time, it's also really like terrifying when you think about what it actually is referring to. And I think that sort of double-sided feeling of saying, like, in some way, there's nothing more interesting than a cloud scale uncertainty, but at the same time, like, we need to solve it somehow so that we can help the planet. That conflict that tension is something that I think I try to bring to my work, where, something's a little like, things are beautiful, but they're a little uncomfortable. There's something that suggests information, but there's no information. It's like sort of hovering on this line between, these two different sides of just conflicting feelings about all of this. Which brings me to this series, which was the specific one that I was having a crisis about in terms of using the data. And I was, a couple of years ago, I visited this, it's in Finland, it's pronounced Hötiala. It's a forest research station run by the University of Helsinki. And they do a lot of things there in addition to, well, they do a lot of forest studies, but then they also have an amazing atmospheric sort of research bunch of equipment sitting there in the middle of the forest. And I picked one photo. It's hard to pick one photo, but for example, these plexiglass boxes are on timers and they go down, and then they're basically measuring some kind of exchange between the atmosphere and the plants in this little box. And it sucks the air in through these tubes into this hut, and there's all these machines in the hut. And, anyway, it's really sci-fi and kind of weird and kind of amazing. But anyway, all of the data that they collect gets published on their website. And for the days that I was there, which was 2 weeks in June of 2023, I would go on the website, download the day's data at the end of the day, and then Photoshop out all of the units so that, they're just these kind of abstract graph marks. And then I would pair them with my own abstract marks. And then these pieces, they're very small. They're like this big. They're little sheets of aluminum, cover them with graphite, and then use a laser cutter to laser etch the image off the surface. And so there's this, there's this question of sort of revealing something out of the dark, this process of like basically making information by removing the material. And then the fact that, in some way, you don't even know that this is information at all. And so, yeah, I called the piece Certainties as the opposite of uncertainty, even though there's certainly no certainty in here. But there's 15 of them. I made one for each day that I was at the station. And yeah, I guess I should say that, I try to respond to the types of imagery that the data is coming through as. So, these are just these like, everyone would say there's just these boring little graphs coming through on the screen. I've always really liked graphs because they're these little narratives. Even if you don't know what they represent, it's like a change of something over time, and this jumps to here, and I think that's kind of interesting. But it's not photographic. There's not really even much color. And so dealing with them in this black and white or grayscale kind of setting made a lot of sense to me. Speaking of those data collection machines that are in the forest, something that I have done on and off for a while, for many years actually, when it makes sense, is to go and try to make sound recordings of the equipment that's doing the measuring. And so I take contact mics, which I think are like little stethoscopes for the equipment, and then sometimes regular mics also, and then just record the sound. And usually it's just a bunch of humming. It's not really like anything. The scientists, when I've asked to do this in the past, are like, I don't know what you're going to find, but go ahead. So this video, the whole thing is online if you're interested. I'm just going to play 1 minute. It has two sections. There's a Finland section at the beginning and then a Barbados section at the end. I wanted to put these two landscapes kind of in conversation. This is 1 minute from the Finland part. And the sound is recorded entirely from the machines that are measuring this forest. Yeah, that was fun to work on. And just being conscious of time here, but the layering of the images is something that I do a lot, as you saw for the first piece. But this kind of photographic practice that I have, which has been going on now for a long time, where it's a response to a feeling like it's impossible to represent a place accurately through an image. And so then what it becomes is I take a series of images, I make these kind of constructed versions of that same place that retains characteristics of that place, but is not trying to actually be or really look like that place. And so I've worked in this way for a long time. It's also a way of like sort of collapsing time because it's different viewpoints at different moments to be putting into one moment. So I'm just going to scroll through these kind of quickly, but there's, oh, this title is wrong. That's not where that is. This is in New Mexico in the US. That's the correct place. And with this series, these were really fun to make, but it was kind of trying to both respond to actual contours in the land, but then also shapes that I would draw in response to it. And there's basically always with these images, trying to find a balance between flatness and depth. And the image overall is meant to appear very flat because sort of contrary to traditional landscape painting or landscape photography, where we are invited to imagine ourselves to walk right into the frame as if the landscape was for us. This is more about kind of reminding you that you're looking at an image and that it's not, it's not somewhere that you can actually go. It's been translated by these mediating processes, myself included. And the shapes are, again, responses to the images or the contents of the images, interest in this flatness and depth, but also a kind of marker of my hand as the artist of saying, you're looking at this through me. And then, yeah, could go into more depth with these, but I want to just end with this project, which is a little bit hard to see in this photo. So I pulled up a digital image of one of them, and I can't move that at the top, but sometimes images can't tell you something. Images cannot tell you how humid a place is or I don't know, that's one of my favorite ones. It's just like you're trying to convey humidity. You can't really convey it through an image very easily. There's many other things that an image can't tell you, and sometimes we need text to do some of that work. And I'm interested in the way that text can become images itself. I actually wonder, someday I would like to ask a neuroscientist what the difference is between looking at an image and then reading a description of something, and what that actually, where that goes in your brain, because I've always wanted to know the answer to that. But anyway, this was a poster project that I worked on with a graphic designer in New York, or a studio in New York. And we had this idea of trying to make weekly posters that memorialized the weather of one moment. And so what we would do every week was, based on wherever I was at the time, they would send me, you know, the numerical data of, you know, down here, the temperature, the wind, the humidity, and the pressure. And I would go outside, I would write, you know, sort of poem-esque text that was describing something about my experience of that weather in that moment. I would send it back to them, and then they would pull some satellite imagery and put it all together in this poster. And at the top, which you can't quite see, you can sort of see in this one, it has the time zone, date, and then location of where I was. And so we did this every week for a year. So there's 52 of them. The way that the project worked was that we did this through, well, theoretically, anyone could get a poster from Staples, which is like a big office store in the US that you can get print on demand. And the poster would be available for 1 week until the next poster came out. And I don't know how many people actually ordered the posters. I think this was the first week. I think a few people have this one, but it was kind of this interesting, like, unlimited, limited edition idea, as a way of trying to sort of, I don't know, yeah, memorialize this passing moment. So that's where I'm going to end. Almost right on time. And yeah, thank you.
Thank you, Andy.
No worries. Hi, everyone. So I'm Andy Hogg. I work at Australia's climate simulator, ACCESS-NRI, and I'm going to inject the science into this discussion and talk about particularly weather and climate research and how we use images in our work. I feel manifestly unqualified to talk about art, but I think some of the images that I'm going to show you have a fair aesthetic value, and we'll see if you agree with that. I think for us, we have an interest in getting messages across. You know, climate scientists have a you know, a pretty serious message that we're sometimes succeeding and sometimes failing in getting across to the greater public. And I think that something that we need to do as climate scientists is take advantage of the richness and the dynamic nature of the natural system, while at the same time being true to our scientific beliefs and our scientific findings. So believe it or not, there is actually a lot of information content, genuine information content in this image. It's a way of classifying different waters in the ocean, and an oceanographer could see some of the dynamical patterns that are occurring here. And so I guess that's something I'd like to emphasize, is that as well as getting across beautiful images of the Earth system, I'm very interested in what the information content is, and I'm less effective as Leah in thinking about how it makes me feel. That's certainly not, or in considering, you know, different perspectives or things like that. So that's interesting. So today I'm going to show you a bunch of images that relate to work that I've done, or my colleagues, or students, and many of these images actually come from climate models. So climate models are things that we use to to predict future climate. They're very important. It's the focus of our work at ACCESS-NRI. And without these models, actually, we're sort of flying blind. We don't really know what the future climate will hold for us. So in that sense, they're important. But out of climate models comes also some amazing imagery and some amazing richness of the dynamic system, which I'd like to get across. But I feel like it's a bit hard to expect you to understand that if you don't know what a climate model is. And it surprises me because I talk about them every day, but very few people understand what a climate model really is. So I'm going to try and share that with you today, and we'll see how this goes. Climate models are, in many senses, much maligned objects. And most people who think of modelling, they probably think, well, you pull in all the data and you use that data and somehow an outcome comes out. And that's actually, that's not the case with climate models. Climate models are based on these things, which are equations. This is actually a oversimplified set of equations that we would use to solve for an ocean model. Okay, I've just picked one at random. It doesn't really matter what it is, to be honest. And it basically represents things like conservation of momentum, conservation of energy, conservation of temperature or salinity in the ocean, all the ocean's equations of state, things like that. And we've got a lot of confidence that we know the physics of this equation, that we understand what these equations are saying, and that they adequately represent the ocean or in the atmosphere or whatever. But actually, there's no solution to them. You can't just solve them, okay? If we could solve them, we could do an amazing job of predicting climate, weather, and everything, but we actually cannot solve these exactly. So we're going to do what we can to solve them approximately. And now here is where here we go. So how do we solve them approximately to make a climate model? Well, we're going to take the globe. This is the Earth. And we're going to actually need a little bit of data at this stage. So we sort of need to know where the continents are. And we need to know, what the land surface is like on those continents, and maybe the depth of the ocean and things like that. And once we have that, we'll take the globe and we'll chop it into stripes. And this is the boring bit. And then we'll chop it into little grid boxes. And so any location on the Earth will sit within one of these grid boxes. And for each of these grid boxes, actually, there's sort of, there's height as well. So this is three-dimensional. So we could also take that grid box, turn it on its side, and we'll stripe it vertically. And then out of that, we'll take a little grid cell, which is what I'm showing here. And the key thing is, if this grid cell is small enough, we can do a reasonably good job of solving all those equations. The key is if they're small enough, okay? I just want to pause here for a moment to say something I said I'd mentioned to Pia, that this style, I'm not going to claim that these messy cartoons are art, but this style of communication is something I actually use a lot when I used to lecture to undergrads, and particularly writing down equations and things like that. And I'm convinced that actually people remember things better when they see it handwritten, and because they remember the style in which it's done. And so for me, this is a very important communication tool, even though it's not particularly artistic. Okay, so we've got our equations. We've chopped up our Earth into tiny little bits. But the problem is, because these equations can only be solved on bits that are tiny enough, we need lots of bits to find a solution for the whole globe. So we need something like this. This is NCI's Gardy machine, which will often run jobs that use 20,000 computer cores at once, using these sorts of models. And of course, there's a lot of work in getting these equations and this grid into that system. That's the software job that we're all engaged in. And out of that process pops the natural beauty of the climate system. And so this image here is taken from an ocean model, and it shows the currents in the regions around Australia. And the amazing thing is that there's no data from observations here. This all comes out of those equations pieced into the computer, and out pops this really rich array of information, which I find still quite amazing, particularly that we can do such a good job of representing the entire Earth out of a set of equations which we've plugged into a computer. I mentioned that many models, you know, your expectation on a model is that it needs some sort of data. And the amazing thing about the climate system is how it's a very, very almost closed system, by which I mean, if we create a model for the atmosphere and we create a model for the ocean and the land surface, and if we have a little bit of data like knowing where the continents are and what the CO2 concentration is in the atmosphere, then solving for this entire world just needs one input, and that is the amount of sunlight that's coming in from the right-hand side here, and everything else is self-sustaining. I mean, that's all you need, and you can run these models for centuries if you have the computer time with just that one input, which is how much sunlight's coming in. Of course, the Earth also radiates temperature and communicates it back out to space, but it becomes a little self-supporting system. Some fields would call this a digital twin. We don't really use that phrase in climate science, but I think that's an important thing to remember. So I'm going to show you a few more things which mostly come out of climate models. This one is actually not out of a climate model. I'm going to start with something that's not. But this is a visualization of the sea ice around Antarctica. And if you want numbers, you can see that what's happening is every year that sea ice is expanding out to a certain distance, and then it's melting again in the summer, and in the winter it freezes again. And its minimum area is about 2 million square kilometres. Its maximum area gets to about 15 million square kilometres every single year. And it's in this animation, we called it the beating heart of Antarctica, because you get this vacillation that just keeps going on and on. And in fact, sea ice was the reason we did this particular animation was because there'd been observations that after years of very stable sea ice in Antarctica, in fact, slightly increasing sea ice area, around about this time, it actually became smaller. And in fact, the last 7 or 8 years, there's been substantially less sea ice than before. I think that the figure was in 2023, the sea ice maximum was something like 7 standard deviations outside away from below the mean, which indicates something's going on there, which we don't really understand. Right. But clouds are where the uncertainty comes. Why does the uncertainty come from clouds? And it's because they're just incredibly, incredibly complex. So this is an image this is a model image. This is produced, all the data in this is produced by a model that we call ACCESS-NRI. It's a 2.2 kilometre resolution. That means grid boxes are 2.2 kilometres wide. I wanted to run that again. There we go. And you can just see these little tendrils that's the wind near the surface, and you can see how strong it is over the ocean, and it's relatively weaker. You also see this sort of flashing, and you think, well, that must be a numerical thing, but actually it's the sun coming up each day and causing convection and creating, you know, across Australia, this sort of burst of clouds in the early afternoon. I'm going to show this again because I find this really interesting. And then you can see all these processes going on at these strong clouds, particularly in the north, tropical cyclones shifting across, and just bands of fronts whipping across Australia. So these sorts of visualizations, I think, are very powerful, because you can think of yourself sitting here in Canberra where are we sitting here in, oops. We'll get there, sorry. Sitting here in Canberra, and you know, what we are experiencing is just that little box just over there when we look up. But that's a product of all these things that are going on across Australia. And I think a lot of people would have a hard time believing that this is not a satellite image when they see this sort of detail in model output, and I find that quite an interesting thing. Okay, back to Antarctica. Something that I want to show you now, and this is that we're going to zoom into this area here in the Ross Sea. So what I'm showing here is actually, I'm showing some sea ice out here, and this is the Antarctic continent. And in a moment, we're going to go right down to the Ross Sea here, and we're going to strip away the surface. And what we're looking at is water that's sitting at the bottom of the ocean. And we pick out a particular type of water that's really dense and really, really cold, like -1 degree is salty, so it can get below 0. -1 degree, and it sits up on the continental shelf, but it's denser and colder than anything in the entire global ocean. So when it gets to the edge of the continental shelf here, this is at about 1,000 meters depth, and this is at about 5,000 meters depth. So when these currents this water gets to the edge of the shelf, suddenly it plunges off like a 4,000 meter high internal waterfall. And when it does that, it migrates all the way to the bottom of the ocean. And once it gets to the bottom of the ocean, it sits there. It's this water mass, if you're interested in the science, is called Antarctic bottom water, and it sits at the bottom of the ocean. And once it gets down there, if it makes its way into the Pacific, it might be something like 5,000 years before it sees the surface again. I like to show this movie because we've had a few movies like this that we've produced over the years, and when I first showed this, I actually showed it at a conference full of oceanographers, and at the end of it, a guy came up to me. He said, "Look, I've been working on Antarctic oceanography for 30 years, and you just taught me something new with this animation." And it really, we're going to be able to clean this one up a bit, but it really gets across the point that what's happening in processes that are hidden from external view, but of interest, I think, to some people anyway. Okay, I think I'm going to stop there. It gives us the time to have some discussion. I guess I just want to highlight that we scientists, I guess, we're very keen to get messages out there, and we're very keen to capture people's attention, but we're maybe not the best qualified to do that. I like to use these sorts of devices. There's a number of people who use these sorts of devices to get messages across to the public. But personally, I think we can probably do better, and maybe the art community is a community that can help us to do this. So thank you very much.
Are we good for?
Yeah.
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 Can I just jump in with a question from the audience quickly? Joe Norton wants to know, I want more of Andy Hogg's videos. Is there a YouTube channel?
Oh yeah.
We all want more of those.
Yeah, we're trying to release some, and we do have a Vimeo channel. If you search for ACCESS-NRI Vimeo, a few of them will come up there.
Yes, we get the lights.
This wasn't the first question that I was going to ask, but it is interesting how we're sort of you've sort of brought this up actually, Leah, around these kinds of different disciplines and the kinds of libraries or lexicons or visual vocabularies that we need in order to understand images, in order to understand information that we're being conveyed. So you sort of have to unpack that, for instance, when you're showing us these videos, to discern what all these elements are that are moving across, and what you're kind of trying to play with those boundaries. Leah, and what dawned on me was how, previous to the World Wide Web, where we were sharing, we didn't have access to these really rich and important resources, and those sorts of lexicons or libraries or visual vocabularies were only held more tightly within the disciplines, and these kinds of practices of communication were kind of secreted. So it's kind of amazing that the internet provides us this access, but then still we have we have this missing link where we're like, but wait, what am I looking at? I mean, it's amazing. It looks amazing, and yeah, I wonder, how much of that you could both speak to, because this kind of I guess this access that we have today has been provided or set up in our lifetimes, really. I mean, I'm doing a vague kind of generational sort of assumption here, but in our lifetimes collectively, yeah. What do you think about that often, or yeah?
Sure. Well, I think it was interesting that Leah said that when you view a scientific image, that you need some tools to decompose it. And I think that's true for, within discipline and the things that we publish. But I think the endeavour with these sorts of animations or these sorts of images that I was showing is that as far as possible, people will know what they're looking at. They don't need narration. They don't necessarily need a subtitles. But by and large, they can know what they're looking at without too much additional information. And I think that's important, partly because people have a pretty short attention span for some of these things, and I know when my daughters are on TikTok, if there's something that they don't understand, they'll just keep scrolling, and so to get that attention, I think it sort of has to be obvious what it is you're saying, and I think scientists need to do better at that, but it's very hard to do, and takes a lot of care and effort.
Yeah, I mean, I think one of the things that got me interested in whether, aside from everything that I said before about just like how landscapes will change, is also that it's a really sort of perfect like nexus point between something that everyone has a relationship to and something that can be scientifically investigated really thoroughly. And so the fact that, I can put up that weather map of the US with all this stuff going on, people might be able to look at it and say like, okay, well, that's a weather map and that's the United States. And maybe I can't get further than that specifically, but I understand that there's a lot going on here. And I think that, to your point, like some of the things that you were showing, even if we can't say like, okay, well, now I can read that this weather front is doing this and influencing this, and there's still this sort of experience of watching it unfold, which sort of gives us this sense of scale and which is something I forgot to talk about, is scale actually. But yeah, it gives us this, what you were talking about, that there's this tiny cube that we're living in, but then when you see the, model or the satellite, whatever, or the Antarctic ice, like that's very visceral to me. And I think that the idea that, people have some awareness that gives them some context for that, for like reacting to that image, in some senses is enough to have the effect that you're looking for, rather than someone needing to say like on a very kind of detailed level, I understand really technically what's going on.
Yeah. And I'm even thinking about, say, for instance, some of those models that you represented, Andy, and your I was thinking about how, you were discussing how your drawing practice, if we want to put it that way, your drawing practice is like, it's important to communicating to the to whoever you're kind of trying to convey this information to. and yeah, that people might actually retain it because of the style that or the aesthetics of your, you know, of your drawing. In the same way, you know, that is like, you know, broadly what, you know, we do in visual art. So I don't know, I think it is perhaps like a process that you use, you know, as a visual artist, like you could say it's a process.
There are good drawings too.
And they have it, but the same thing with the modeling, it has a visual style, right? Like with you're sort of showing us as well. And yeah, I think that's that. My question is, I guess, that style, how much of it do you are you like sort of dictating you know, yourself in terms of like choosing like the visual qualities? Do you think about that much, or is it really just about like it being as obvious as possible, to you know, making it as obvious as possible to a you know, to somebody who's watching it?
Yeah, and I think
Like
there's
there's
two opposite.
darkness, for example,
Yeah,
for instance, or there's contrast, or there's sort of decisions you're making in terms of color, that, you know, imagistically that we're, you know, that we use in visual arts, that yeah, one wonders.
well, to be honest, I don't think about it all that much.
Okay.
Particularly with the drawings, I just kind of scribble what I'm thinking and hope that comes out. But with those higher end visualizations, I didn't do them myself, actually.
Yeah, when I say you, I mean you and your gang.
Yeah. I mean, I have done stuff, but it's not as good as that. And I think the people who do that work, there's a couple of guys at MCI here in Canberra, and we've got one based at ACCESS-NRI who lives in Melbourne, and they're both mathematicians because they can understand all the maths and their computer programs, but they're also, you know, very in tune with the aesthetic, and so they think about that a lot. And the first time we did one of those Antarctic bottom water movies, the guy, I mean, he spent 6 months on it thinking about, you know, how the light, you know, what shading he's going to use, what color he's going to use for the topography. So I think a lot of thought needs to go into it for that high-end visualization to look good.
So then there's some interesting connections that you made. Yeah. Who is that? So I'm going to draw along the bow now, which is like about, I was thinking about like capturing an image or capturing a landscape, you know, and these sorts of, like all the words like capturing or like they're all quite colonial, like, you know, or like you're out there hunting for an image and you kind of rein it in, to try and, you know, yeah, to you know, represent like a landscape in its present moment, or to represent a landscape and its, you know, broad behaviors that are going on in that moment, and the complexities of that. What do you think about like, I guess, yeah, what I noticed in your work, Leah, is that you have this narrative style that goes over the top. You know, while you're talking about it in this PowerPoint slide or keynote slide, as it was, you're showing us these images and talking over the top. But what I notice also is in your video work, there is a kind of narrative that has to go over the top. Can you speak a bit about that?
Yeah, so this is, there's like a few central tensions to my work, and I talked about one of them in terms of the information abstraction, but I think that tension sort of expands into exactly what you're talking about, which is that, you know, I think there's one version of my work like this where I'm standing here talking about it, and then there's the version of it when I'm not standing here talking about it and you're just looking at it, and maybe there's some text somewhere, but I'm not a fan of wall text in general, and I think that there's something, it's actually, I mean, the way that I thought about it is that I kind of hope that my work can bring something to people who know nothing and people who know everything, meaning people who are seeing it cold and people who are seeing it with me standing there talking about it. And obviously there are going to be different things that come out of that. But it's been a sort of ongoing project to navigate how do I steer this space, which is the people who have no necessarily any context, into thinking about the kinds of things that I want them to think about, even if it's not going to get specific. And so, yeah, I mean, in terms of what you said first about this capturing of I've thought about that, and in a way, my sort of answer, like becoming interested in the inability to capture, it's sort of the way that I started talking about it a couple of years ago was to just let them be the complex things that they are and not try to represent them, and just let it become something else that is sort of coming through me. And it's not trying to impose myself on it to kind of, you know, try to pull it, you know, over here, but more just to say like, this is untranslatable. And so let me just let it become a new thing, sort of through what I'm doing. And so in that way, it's actually my, you know, in some ways, I mean, I really enjoy getting to talk about my work and explain it to people, but I also like the idea that someone would encounter it and that it's totally indeterminate in its own way, you know, and that they are kind of, that a viewer is sort of asked to react and try to make sense of something actively rather than me telling you how to feel about it. So yeah, so that's kind of and I think that, I don't know, I mean, it's a funny thing because I mean, actually, this is maybe something to talk about a little bit. I came across something a few years ago when trying to read about scientific uncertainty that said that, you know, scientists are generally looking to reduce uncertainty. But then, in my opinion, artists, like one of our main goals is to maintain it. And so there's this, and so and I'm really like that kind of tension is also super interesting to me. So like, you know, being an artist and being able to say like, well, that cannot be resolved and I will just leave it there because that's interesting is great to be able to do. But then I recognize the immediate problem when it's like, actually this information is needed to be useful and to communicate at the same time. And a lot of it comes down to kind of context for me of just like, what is the work trying to do? Where is it? And then based on where it is, how are people trying to respond to it? But I think, yeah, I don't know. I mean, as art and science kind of get more and more entangled, which they absolutely are, like that's a, I don't know, it's a, how do you sort that out?
So could I ask, like, the extra information that would allow someone to interpret, you know, a picture that's sitting on a wall in a gallery, that it doesn't worry you that people don't have that information, and that with that information about, you know, what it's representing, it's part of a cloud, this is a microwave sounding in the cloud or whatever, they could make more of it, but it doesn't worry you that they don't have that information, because that would really concern me.
Yeah.
I think really.
I think I've had a changing opinion over the years, and I used to be really stubborn, and sort of fighting for some solution that I couldn't really ever find, which was that if someone needed to know something to understand the artwork properly, then how could the artwork, how could that information be in the artwork without having it to be secondary to the artwork? And I went through, you know, various experiments to try to do that, and you know, would sort of on one end run into my own kind of stubbornness about explaining things and not wanting to explain things and wanting it to remain kind of indeterminate. But then, you know, also realizing that like sometimes you just need that information, and like what's the best way to give it if someone actually needs it. And yeah,
because it's not just information, right? It's meaning as well.
Yes.
What is it? You know, it's not, even just knowing what the data, or if you want to call it that, or the visual pattern is telling us, what do we desire it to be saying, even, there's a whole other layer. And I think you can do that desiring sometimes better without the information.
That's true.
Define better.
Yeah, well, I mean, yeah, maybe it's about true, define better, because it's about, some of it is about, sits in that space of speculation, right, where we want to speculate for a desirable future. And so, if we have a lack of information, then we can do a pretty good job of making one. But with the information at hand and knowing it in detail, we're screwed. Yeah. Okay, I've got 1 more minute, and what I wanted to ask about, 1 more minute before I'm going to hand it over to you, was around, so with the narration, what you're talking about in terms of the narration, to come back to that, would you call it then observation that you're doing?
You mean when I'm talking over it, or
talking over it, but also even thinking about putting together these images, like even looking at the work that you made across those 2 different sort of weathering, I'm going to call them weathering stations, I don't know if that's what they're called, that, and you're kind of scrambling or placing different phenomena together, but with also your own markings. Would you call that, holistically, a sort of observation instead of capturing?
Yes.
You're observing.
Yeah.
You're not dictating, you're observing.
Yeah. And I think that's important to me, is that I'm not, I guess I feel like, I have what I have to bring to the world, as an artist, but I don't want to be some kind of authority on these things.
I love that you said that.
It's just I think, I don't know, I mean, some of it is that, I don't know, I mean, it's all really complicated, because in some way, data can be political, and who is observing and where's the machines coming, it all has its perspective, but then at the same time, people are working to make that as objective or sort of neutral as possible, and so there's 2 sides to that also. And but I think that I was really influenced back in 2016, reading Karen Barad talking about quantum physics, basically saying about how every measurement affects the observation, or every observation affects the measurement. And in that moment, I was just like, I'm just sort of an observer, and this camera that I have is like my measuring tool, and I'm just sort of going around seeing what I see, and I don't want to make any claims beyond like what I am seeing, because I don't feel like, usually I'm in places that I am not from, so I don't feel like I have any kind of like authority over these landscapes that have other histories or other, but yeah, I don't know. But then also I think that we learn things and we gain things by having them filtered through people, so yeah.
Maybe there's the kind of the different parallels in terms of the roles of, someone who's working in fields of science needs to be able to claim the space of authority, and there's a kind of retaliation to that by artists, some artists, not all of them.
But I guess, I mean, I think that, and I'd be curious to hear you speak to this, and maybe it's something that more that scientists out doing measurements speak more to, but I think that I don't know, like I read something sort of related to that, reducing uncertainty, that it's like chipping away at an unknown to find the known, rather than just like doing a measurement and be like, now I know something. And so it's not as like, I think that there's a complicated, like the public and politics like need to trust science, but then at the same time, I think from what I understand, scientists recognize that that things are murky sometimes, you know, and so how that gets balanced and like, you know, it's not like science needs to, no, I don't think that science needs to do anything about it, but I think just as a question, that's something that artists can explore, like in this relationship between the two of like, how, because also I think, yeah, I mean, we're living in a world of uncertainty and nothing's going to change that. And so it's like, how do we manage it? And that's where, how do we engage with things that we don't understand? That's like what art does. And yeah.
And I think, so from a scientific point of view, I'd say scientists are pretty good at understanding uncertainties. And they use it in their work all the time, but they don't always use it in their communications. And that may be partly because the way we define certainty and uncertainty differs from the common understanding. Or it may be that we just try and simplify things to an extent that, you know, that it can be accessed by the widest possible audience, and as a consequence, we leave out the uncertainty, right? And that I think that's been one of the issues. And the IPCC, which is the International Intergovernmental Panel on Climate Change, they've been really they've made a lot of strides recently about how to define uncertainty, you know, moderately likely, what does that mean? Things like that. You might notice the Bureau does this now too with their weather forecast. They say 10% chance of rain or something. And I see 10% chance of rain and say it's going to be dry. Right? But that's actually not what they mean. They actually mean 1 in every 10 times we say there's not going to be any rain, or 1 in every 10 times we say there's going to be a 10% chance of rain, it will rain. And so then, yeah.
I feel like I need to write that. Who would like to ask a question from the audience?
You mentioned the word political, and I'm pretty sure you said it with a small p. At ANU here about, I don't know, 10 years ago or so, a quite well-known climate scientist at the time required security, locked doors, security at his office. Big P politics was well and truly in the space. His life was threatened. It can be an incredibly vexed space. I think some of the heat has gone out of it, but not that much. It remains a very political space. Neither of you have kind of spoken to that. I wonder if you want to tease out a little bit more about the field in which you play. Or not.
Yeah, I mean, that's a really serious one. I mean, the people who have found themselves in a situation like that, I've got a close colleague in Sydney who received notes, I know where your children go to school, things like that, are ones that are very, you know, visible in the public media. And most climate scientists are not actually like that. Most of us kind of shy away from the media attention, but someone has to do it, and there is an implied threat for some of them. And certainly, you know, at that time, we were putting together a major grant, and everyone was saying you cannot put the word climate change in this grant. If you do that, Peter Crennan will put a red line through it. It'll never get through. Full stop. So it was very political then. I agree. I think the heat's gone out of it a little bit, and I think that's partly because it's maybe more apparent to people these days that, yeah, there's actually a visible signal of climate change. Maybe people are used to it. I don't know quite why, but certainly in Australia, we don't seem to be having the same political arguments, and I don't seem to have to persuade people that climate change is something that is happening and has happened.
Hallelujah. Not the case in but I think I mean, it's interesting because there was an essay that I read by a theorist a couple months ago. It was written maybe in 2018, and I'm forgetting the large details of it, but it started with an analysis or a sort of reaction to the hockey stick graph that was so famous, and basically sort of talked about the ways that as an image was contested from different sides, you know, and the way that it wasn't just the image, but it was like the data that kind of built the image. And so the idea that this little thing that's just kind of like a line, you know, that itself could be that charged politically was really, you know, fascinating to me. And I guess that kind of brings it back to what we've been talking about, which is that, you know, like, you know, sometimes words are more powerful and sometimes images are more powerful. And I think that people in both the sciences and in arts have been trying to figure out, like, what are ways of communicating the impacts of this, you know. But I think that there's I don't know, I mean, to me, it makes me just think about different kinds of visual literacies that people do or don't have, you know, and that, like, if everyone in a sort of society was trained to look at what you're producing and could just look at it and say, like, I see what's happening, you know, I don't know, there's something kind of in there in terms of just like general knowledge, how to look at something, how to look sort of critically and understand it, and rather than to just be like, you know, I'm going to write this off because it's against my political views.
Yeah.
And I think that that's something that, you know, I mean, I tell my students that I hope that, like, even if they're not going to be an artist, learning how to look at something that's unfamiliar to you and to engage it is a skill that we all need to have in terms of dealing with other kinds of people or other perspectives. But then, you know, the flip side of that is that if we all just sort of had a more common sort of understanding of some of this stuff, then maybe it would be smoother, you know, and
you know, Chaitanya.
I just have a quick question from the online audience that directly relates to that point. So before we move on, unless yours directly.
Also.
Oh, okay, you go. Go.
Hey, so, you sure?
Yeah.
Okay. Taking that further, next step, thinking about the political as well as the economic and the global. There are vast populations in the world who are either indifferent, hostile, or unconcerned to the questions that we're talking about here. There are many billions who are entirely occupied with finding and maintaining the means for basic survival. In this sense, the work of the artist or the climate scientist producing images, animations, seems to me needs to be necessarily invested in making a change of heart and of behavior amongst vast populations. So in communicating the existential threat of climate change, do artists and scientists embody an avant-garde position in the manner, for instance, of those constructivists who made work for agitprop trains traveling through rural Russia, trying to get people on side, trying to change behaviors and attitudes? Is that not necessarily part of what we must do?
it's a tough question. I mean, I have sort of a sarcastic thing that I always say, which is that if I really want to help the planet, I should go clean up the beach, you know, instead of trying to make art about it. And I think I don't know, I think it's a very personal kind of view, and I think it's also a very, I don't know, I think it's, with art, there's so many different contexts. And so I think, to your point, there are, I totally hear what you're saying in terms of, like, is this relevant? Is this immediate? Is this necessary? I think that, I think all of it's necessary, I guess is.
I won't at all mean to say, is this relevant? No, I totally agree
Relevant.
it is relevant.
Yes.
But what I'm trying to say is that the questions we're talking about, the aesthetic decisions that are being made, you know, what color do we wish to use? You know, those decisions are embodied or imbued with that with that next step of, why are we making those decisions? I'm not in the least questioning the relevance of what's happening. I'm actually asking that next question around, where to whom do we speak and how do we speak and to what end do we speak?
Do you mean sort of like, it's almost like not just the production of these images, if you like, but the mode of their dissemination? Like, how do we disseminate them? It becomes like the next.
And in fact, to support a wider dissemination of it is where I'm trying to come from. I'm not questioning the relevance at all.
Yeah.
Because we're speaking,
Yeah, we're all in the same on the same page.
Yeah.
I think so.
Yeah.
Look, I mean, I feel like a lot of, there's a lot of different approaches. There's the, activism sort of approach. There's people who say, well, if I'm going to save the world, I'm going to go make cheaper solar cells or better batteries or whatever. So there's, I mean, I think it takes an enormous amount of people working in different spheres to actually affect the change. And so I don't think there's a right and wrong about how we affect that change. I think it comes from individual actions that form a collective, and that takes many different perspectives and different inputs.
Once again, I want to clarify, I'm not trying to deny it. I'm speaking within the same community. I'm not trying to say that you are wrong. So there's no right and wrong question. Actually trying to support the conversation to the next stage.
Yeah, I mean, oh, go ahead.
We'll just need to move on to the Zoom questions.
Yeah, I've got about 3 from the online audience here, but I just wanted to jump in with a follow-up from Joe Norton. Hi, Joe, who is online. And Joe was saying, should artists be responding more loudly to the sustained attack scientists are under currently? For example, the US government removing all data sets from NOAA that support the existence of climate change.
Well, I think that people are doing that, and there was a project that someone I know did during Trump 1, which was encoding data that was being deleted from the servers into images of the weather stations that had been collecting them, and over time you could see that all the colors of the images changed, but then there were ways of decoding the data back out of the images, and I thought it was like the best data viz project I had ever seen. It was amazing. And so I think that people are doing it. I think that for a lot of artists there's a skill gap in terms of dealing with data that in the US is starting to change slowly. But I felt for a long time in different contexts that and for good reason, we teach traditional media in art schools. Those media are important, they should be preserved and people should still work in them. But there's also, there's so many new things, and it's hard for people to learn it all and to be able to, so it's, but the more that sort of technology code, data coding, whatever, like skill gap is addressed for artists, the more projects are going to be like that, I think.
I just add that we've talked a lot about this, no satellites, etc., in recent months, and I think the general view is for too long we've been reliant on US public good science funding, and it's probably time that other nations around the world funded things for public good rather than economic output, and we're probably going to see a reduction in publicly available data that can be used for climate projection or ocean state forecasting or weather prediction, and that's and it's partly our fault for being entirely reliant on one nation, which just happens to not be wanting to continue to do that.
Well, Andy, I have another question for you, if I may. Joe has asked, sites like Windy do a great job at making climate science and meteorology accessible and fascinating. Do you see any obvious gaps in where scientific knowledge needs further attention from visual communicators to extend engagement with the general public?
Yeah, I'm sure there are many gaps. I mean, Windy's an interesting one because Windy's taking actually a forecast product from ECMWF and putting it on your phone. And in fact, it's not just ECMWF now, it's other agencies. So they're taking global forecasting products and just making it available. Anyone could have done that at any time. And so I think Windy does do a really good job of that. And if you haven't already downloaded it, have a look at it. And it's probably a more accurate forecast than you get out of the bureau pages on some occasions, not always. So can we? Are there gaps? Yes, there are gaps. I guess there are too many to name. But you know, scientists are not necessarily trained to communicate in the visual arts, and that's why we're here, I guess. Yeah.
Any other questions?
I have a question, and then we'll have one more online.
Okay.
Yeah, it might not be a long answer necessarily, but I was just wondering if there's some specific things or types of data you'd like to visualize or see visualized, in the future. Or both of you. Yeah.
I mean, for me, I'm interested in the links that people go to make visible what's invisible. So in that sense, I'm kind of, I'm kind of just like responding to what people are seeking out. And which actually gives me a thought about what we were just talking about before you answer, which is that I think that, you know, with something like Windy, we all are like, oh, well, there's wind and I can go one-to-one here, you know, somehow. But the idea that there's so many things that could be mapped that we just don't even know our parameters. And I think that it's like, there's I don't know, it's like in life, there's always more that you can know about something, and having like a sort of respect for what you don't know, I think, you know, and letting that be a gap that someone else has knowledge about, I think is like an attitude that would be, you know, better off if we all, so yeah, in that sense, I defer to you for that question.
Look, there's so many variables and so many things we can visualize. I think I like to visualize things that bring out, you know, physical climate phenomena or biogeochemical or whatever that are important. So again, this comes back to me trying to communicate things. So for example, to be able to visualize phytoplankton in the Southern Ocean and how they pull chlorophyll into the surface ocean. I mean, that sort of thing, it's just amazing. It's a combination of biology and the fluid mechanics of the ocean. These sorts of things I find really, I guess, the most interesting. Yeah.
Okay, so there's a lot of things.
Yes, there's, you know, hundreds of variables that pop out of a climate model, hundreds of things being measured from satellite of the Earth every day, from the whole constellation of not just the US, also European, Japanese, Chinese, Indian satellites that are all measuring an amazing amount of Earth observation material. Yeah.
Okay, you don't feel a lot of that's being communicated to the general public?
Well, I think there's so much of it that, yeah, there's only so many channels to get these out of.
Right, yeah.
So many supercomputers.
Yeah, about that.
So many different numbers, yeah.
Final question? Yeah, okay. We're going to be talking about that contested word beauty, which the artist Richard Moss said is like one of the sharpest tools in the artist book. And artist Heather Burness online has the following question. I wonder if any panelists would like to talk about beauty and its relationship to the data that is visualized. Also, the idea of the poesis of the image. Its visually compelling nature to the viewer. Do we just need more beautiful images to solve this problem?
My response to that is that which is also something that I've felt conflicted in different ways about at different points, is that I do tend to try to avoid in the images that I take, photographic images that I take, direct evidence of humans. And the reason that I do that, or other animals, actually, other creatures. And the reason that I do that is because I felt like, whether it's a building or something broken or something destroyed or a butterfly or anything, like the minute something flies into the frame, it becomes the protagonist and the landscape becomes the background. And I'm interested in the landscape being the foreground. And so in that sense, it kind of leads me to trying to look for something that is comparatively natural. Of course, beauty is a part of that, because I'm an artist and I want to make beautiful things, but I also like making weird things. And so but I think that my interest in these beautiful places comes from wanting to be in a space where the landscape can be in the foreground, rather than being like part of some sort of larger narrative, and to get us to think about the systems that have produced that landscape. So that's my response to it.
I don't have a great response to it, other than I find things are beautiful when they represent the full complexity of what you're looking at, and so that's what I strive for, is to represent as much complexity as we can, and I think that often produces things which I think are beautiful, which not everyone will agree.
I think that's a really good place to end.
Beautiful.
Thank you.